Hello everyone, I'm Massimo and I'm a member of Team MLG, together with Luca Bertelli and Gabriele Bonanno. Let me introduce you to our project. Vocal assistants are in our everyday life. We use them frequently anytime we need quick responses, but sometimes they don't answer immediately. This is because their hardware, typically a general-purpose computer, is not optimized for speech recognition and works sequentially. Our brain instead is best suited to do this task, so we want to emulate it on an FPGA by implementing a neuromorphic circuit. General-purpose computers work by scheduling tasks and executing them one by one. They simulate neural architecture in order to recognize speech via software. This becomes a bottleneck when the flow of data that needs to be elaborated is large. The audio signal of the spoken word is passed through a filter bank in order to get its frequency spectrum, which allows us to compare it with the keyword that is to be detected. The spectrum is inherently parallel, as the whole has to be processed for every word heard. A parallel architecture is best suited to process it all together, without having to schedule tasks sequentially, thus reducing the detection time. We believe that by implementing the keyword detector via a brain-inspired circuit on FPGA, we would ultimately be able to speed up the detection and reduce power consumption. Let's see why we think this could be done with an analogy to a more familiar concept. Let's suppose we have a Boolean function that gives logic 1 as its output only for a specific combination of the inputs. There are two ways to implement it. The first would be to write a program on a general-purpose computer. The second would be to create a logic circuit with that exact function. It seems obvious that the latter would lead to a faster result and greater power efficiency. A neuromorphic circuit follows an approach similar to the logic circuit, but with a substantial difference. The correct input is not only a unique combination, but it could also be one which is similar to the ideal. This makes it robust to input variance and thus able to detect the keyword in a wider range of situations. Even more importantly, a neuromorphic circuit is not static like a logic one. The architecture can be reconfigured simply by changing its parameters, making it a dynamic system that can be continually improved. Thanks to our brain-inspired device, we could be able to recognize the keyword directly, without the need of the unnecessary hardware of a general-purpose computer, thus reducing power consumption and making it suitable also for today's portable devices. Thanks for watching.